Hello everyone, and welcome to this video about using OpenR interface inside R2lab. So what we're going to do today is to take this tool named Cube5G and exposed by the OpenR interface consortium. This tool is able to deploy an LTE network as a CNF and VNF applications. And we're going to get it to run inside our tool, R2lab. And R2lab is, as you know, a shielded electromagnetic room where you can run radio experiment without being affected by the outside radio traffic. And to this end, we're going to use a dedicated script that we've written exactly for that purpose. So the script itself is located in its own GitHub repository, and I have it on my Mac computer. And I'm going to run it without further ado. So the script goes like this. You can, of course, run it with a -help option that gives you the details of all the options you can use. You also have the README that gives many explanations on how to use it, and in particular, it's going to describe several options that we have in terms of strategies. Strategies meaning how we want to have the different pieces deployed inside the cluster. So the first option that we're going to exercise is -dry run. The dry run mode obviously does nothing, but it shows us which nodes would be taken for which function. And let's remember that fit01 is going to be used as the master node for the Kubernetes cloud, and that fit23 is going to be used for hosting the enode B. And this is important because the enode B node, of course, needs hardware characteristics which are not necessarily present on every node in the platform. Okay, so before we actually trigger the script, let's go to the R2lab main page just to make sure that the testbed is all off. And for this demo, we're going to use the -0 none option. The reason for that is we want to be able to choose the strategy later on. That is to say, we're just going to deploy the Kubernetes infrastructure, and then we will interactively deploy the network later on. In the meanwhile, let us see what exactly is going on. So for that, we have a PNG file that is created by the script itself, and that gives indication of what's going on. So in a nutshell, we're going to load hardware images on top of the nodes, and there are two images involved, one for the master node here, and one for the 3 worker nodes. Once this is done, we're going to set up the Kubernetes cloud in this particular sentence, kubeadmin init, on the master node. We're going to go to the 3 different worker nodes and request them to join the cluster. And once this is done, we are going to finish the preparation on the master node by creating one pod that is going to host the Cube5G operator, primarily this. Once all this is done, we're going to wait for a little while that everything settles. And at that point, we will be able to control our deployment. All right, so we can focus on the active nodes while they are being loaded, and then we have to wait for a little while. Okay, so the last stage was about triggering the operator, and at that point we have 4 nodes as part of the cluster and one pod here which hosts the operator. At this particular point, we only have one functional cluster, one functional operator, but of course there is no LTE network at all, and we are going to start it ourselves. All right, so now that the script is finished, we are going to be able to go to the interesting part, which is to control the cloud, and in particular to pick one strategy among the ones that are proposed. So to this end, I first need to SSH into the master node. I'm going to do it in 2 hops. And from the gateway, I need a second hop. And now I can follow the instructions from the README. So I first need to go to the appropriate directory. from there, I can see that I have 4 nodes. I can also see that at that point, I have one pod, which is the operator pod, that I can instruct it to deploy 5G operator, deploy V1, and I'm going to choose the disaggregated core network mode. Oops, yeah, sorry. So at this point, the Cube 5G operator is doing the deployment for me. I can see its progress by doing kube control get pods a couple times. At this point, for example, it deployed the database and the HSS, which is currently being deployed. I have to wait for a little longer. The interesting part is I have the option to change the resource description, the Kubernetes resource description file, in order to tweak the choices that have been made. So for example, with this scenario, I am using this file where, for example, I can see this part that says that the node which is going to have the OAI label, the Kubernetes label set to run, is going to be the one that is chosen to host the eNode B. Well, you can tweak anything you want in these CRD files. And then after a while, at this point, we still do not have the network deployed. And I can see the last pieces currently being brought in. So I can now go to the phones and check their connectivity. So for this, I'm going to log out of the master node and still from the gateway, this time going to, for example, node number 2, which as you can see on the map is currently turned off. It's the airplane mode. So I can do something like phone status to check that it's turned off. I'm going to turn it on. I'm going to see whether its connection is. It is not the case because the radio network is still not on. So let's turn it off again. And let's be a little bit more patient and try again. So now we have connectivity. We can actually ping the outside world. That's perfectly fine. And we can, as usual, go and examine the screen. We can interactively manage the phone and, for example, run a speed test. So you can see that the phone is correctly connected with the 4G. And we can, for example, click on a speed test session and measure actual throughput by doing, this kind of things. So all this should give you a fairly good overview of what you can expect to do with this tool, especially if you remember that this deployment will always use the latest stable software from OpenAir interface.